This is a quick video about using SPSS in order to carry out a chi-squared test. Use a chi-squared where you have nominal data as opposed to rank or ordinal, and obviously here we've got names or nominal data which we've thrown into the sheet. It's a very small sample, but it's sufficient for the purposes that we have here. So the first thing we've got to do is go to Analyze, down to Descriptive Statistics, over to Crosstabs. I'm just going to reset on this one to take you through it. So we're going to have obviously smoking and gender. It doesn't really matter which way around we do it on this particular set. We need to go to cells, and we want expected values as well, because we're comparing the observed values to the expected on a chi-squared test. Click continue, and we also want to look at statistics. Now the reason is this: with a chi-squared test we can see whether or not there may be some association between our two sets of variables. However, we don't know how strong that association is. If we want to do that, we need to carry out an additional test, which is why we're clicking on statistics now. And if you come down here, apart from clicking on chi-as-well itself, you also need to click on phi and Kramer's v. Now the phi test will be absolutely fine with what we're dealing with, because we've got a 2 times 2 table. If we were dealing with a table which was greater than 2 times 2, you would use the Kramer's v. So we click on continue again. So we've now got our two sets of variables in there. We've set everything else up for the chi-squared test, and we'll click OK. And we get the tables coming through. Now we can see straight away when we look at the cross-tabulation table here that we have got a difference between our expected counts and the actual count. So we can suspect that, yes, we're going to see that there is some significant difference. Now if we come to here, we can see that we have got different values here. So we've got the chi-squared test at 1.688, degrees of freedom of 1, and the p-value or the alpha at 0.194. Now this, as the alpha was automatically set at 0.5, or at 5% I should say, we can see that it's less than the alpha, and therefore we do have a significant difference. Now the other thing we need to be aware of when we look at this is this one here, saying 0% of cells have expected count less than 5. There is an assumption with the chi-squared that the count for each cell will always be more than 5. If it's less than 5, you can't rely on it. But on this occasion we can see that every cell has at least 5 in it in the count, so it's safe to go ahead. Now as I was saying, we saw that we've definitely got some association. Now we can look at the degree of significance now if we go down to the phi score here at 0.250. Now we'd have to look this up on a set of phi tables, or the standard tables, and it would show that in this occasion we have got a moderate degree of association between our data sets, in which case we would say that the null hypothesis has been rejected and the alternative hypothesis has been accepted, and the alternative being in this instance that there is a moderate association between gender and smoking.